Morning everyone. Today we will be looking at waves, sound and light. This is just an introductory lesson into the different types of waves that we get, and more specifically transverse waves. So when we talk about a wave, I want you guys to literally imagine a wave like you would see on the ocean, a wave like that. When we have a wave that looks like this, we call it a transverse wave. You will see in the notes that I compiled for you guys, a transverse wave is a wave that has a disturbance, or you can call them pulses, that is at right angles to the direction of the movement of the wave. So what this basically means is, if the movement of the wave is that way, that direction, let's say it's going to the right, all right, then you will have your transverse wave in right angles there. That's all it means, all right? So it means basically that the wave is going up and down. That's what it means. Okay, now what are waves composed of? Waves are composed of a series of pulses, okay? Now think of a pulse. Think of yourself holding a rope or a hose pipe. And when you flick it up, there's a little pulse that runs along it. So when we have one pulse and another pulse, we get one wave. And from there to there is the wave length. All right. So let's say, for example, we put this wave on a graph and we label the graph and we number the graph. We say that is 4 meters, for example. And we say that this, for example, is 2 meters and that is 4 meters. Then you can see that the entire wavelength is 4 meters if we measure it in meters. From here, this is the position of rest. From the position of rest to the top of the first pulse, we call this top part the crest. Right, and the bottom part we call a trough. Okay, from here to there is called the amplitude. Amplitude basically it tells us how high the pulse is. Okay, so when we have one crest and one trough, we have one wavelength. Let's go and look at the different interferences that we get. Let's say, for example, let's go and look at constructive interference. Let's say you are two people standing on the side of a hosepipe, and you are flicking the hosepipe up, and your friend is also flicking the hosepipe up. This wave or this pulse is moving in that direction, and this one is moving in that direction. When they overlap, because they are on the same side of the rest position, when they overlap, it's going to cause a big pulse, and we call this a superposition. This is the superposition, and this is called constructive interference. Constructive. Think of building, you're making it bigger. Once the interference took place, afterwards, these two pulses will continue in the same direction as they were going before the interference. So they're going, interference, and then they continue in the same direction. And this is called constructive interference. Let's say, for example, you are standing here with your hosepipe. You are flicking the hosepipe up, and your friend is flicking the hosepipe down. Now this pulse, the pulses are moving towards each other. When they interfere, what's going to happen? Let's say the amplitudes are the same. What's going to happen? They will cancel out. So you won't see an interference. And we call this destructive interference. So destructive interference happens when we have pulses traveling towards each other that are on the opposite side of the rest. the rest position. After the interference took place, the pulses will keep going where they were going before the interference happened. Okay, I did explain it to you guys in your set of notes. Then just one more thing, points in phase. When we have a wave, let's say we have a wave like this, and I label it A, B, C, and D. All right, let's make this point E, F, and G. When we want to determine how big or how long a wavelength is, we need to look at 2 points in phase. When we talk about points in phase, it means it is 2 points doing exactly the same thing at the same time in the wave. So this sounds confusing, but it's really not. It means that if we have a point there and there, you can see that both of them are right at the top of the crest. Or if we have 2 points here, there and there, you can see that they are at the bottom of the trough. Or if we have a point there and there, you can see that these points are doing the same thing at the same time. Or this point here and that point there, you can see that they are doing the same thing. So these are called points in phase. Points in phase are points on a wave doing the same thing or moving in the same direction at the same time. And one wavelength, which we indicate with the lambda sign, is between 2 points in phase. So let's go and have a look. If I ask you here, let's say we draw a graph here, and we say this is 0. I'm going to fill it in here. You know it should be on the x-axis. 0, 2, 4, 6, 12. And I just give you this wave. And I ask you, and let's say this is in meters, the distance or the wavelength. I ask you, how long is one wavelength for this specific wave? Then you simply go and look for 2 points in phase. You will also notice that between 2 points in phase, you will have 2 complete pulses. 2 complete pulses makes one wavelength. Okay, so let's go and look. A and C are both in phase because you can see they are moving in the same direction at the same time in this wave. So then you can see, all right, my wavelength is 8 meters, one wavelength. You can go and test it with different points in phase. Let's go and test another point. Let's move between E and G. E and G are also in phase because they are both at the top of a crest. So we go from E to G, and you see there is half a pulse plus another half a pulse, which gives me 1 pulse, plus another full pulse. So I've got 2, look at this, 2 complete pulses, and this gives me 1 wavelength. So from 2 to 10, we've got 8 meters. That confirms that my wavelength is 8 meters. Let's just quickly recap what the amplitude is. Let's say I go and mark it like this. All right, on my y-axis, and I say this is 3 meters and this is 6, 9, etc. Then you will see, all right, your amplitude is 6 meters. That's your amplitude. So you can assume that this amplitude is also 6 meters and this one is also 6 meters. The amplitude will stay the same if the wave is moving at a constant speed. Okay, so those are your transverse waves, your destructive and constructive interference, and the explanation of how to work out a wavelength.